Hello, I'm Jonathan Jesus, and this is my video report for homework 3. So for our first assignment, we were to create a program that reads in 10 numbers from the user and then outputs the unique values. I started by declaring the variables that I needed. I needed a num variable to allow for input from the user, a numbers array that stored these values, a bool copy which allowed the program to determine whether a value was a duplicate or not, and also a count which counts the number of unique variables in the array. So I started by making a for loop to gather input from the user. And after this, I created a for loop inside this for loop that determines whether a number is a duplicate or not. It does this by comparing num, which is the value entered by the user, to pretty much every number inside the array. And if it's true, copy is set to true, and then it breaks out the array, and then it goes to here. So if copy is true, this will not run. So the only way this runs is if there's no duplicate. So if copy is equal to false, numbers count will be equal to the number entered by the user, and count is initially at 0. So after this, we iterate count by 1, we add 1 to it, and then after this, we set copy equal to false to prepare it for the next iteration of the array. And to output this, I just made a simple for loop, which goes to 0 to count, and it just outputs the unique numbers. So I'm just going to test this right now. So I'm going to enter 1 once, enter 2 twice, enter 3 twice, enter 4, 5, 16, 16, 11. And here you can see enter 2 twice, but it only outputs it once. Enter 3 twice, it outputs it once. And enter 16 twice, and it outputs it once. So you can see my program correctly displays the amount of unique variables entered by the user. So for 3.2, we were to create a program that generates 100 random integers from 0 to 9 and then outputs the count for each number. So I started by declaring the variables I needed. I needed a numbers array to store these 100 values. I needed a count array to store the count for each number from 1 to 0 to 9. I needed a C integer variable that would allow me to enter in the count into the count array. And also had a 10 variable that allowed me to have proper spacing for the output. So I started by making a for loop to populate an array with random numbers. It just uses the rand from this library right here. And then after creating this 100 value array, I run 2 for loops that determine how many like counts there are for each number from 0 to 9. So it starts from 0 and goes all the way to 9. And for each variable or for each number, it will go through the entire array of 100 values. So if 0 is equal to a number in this array, it will set C. It will add C. It would add 1 to C for every number. So if there's 10 instances of 0 in this 100 number array, it will add 10 to C. And then after this for loop ends, we add that value into the count array here. So it will enter in 11 for count element 0. And after this, we set C equal to 0 to reset the count for the next iteration. And then here, I just have a simple for loop to output all the numbers inside the 100 random value array to make sure that my program was right. And then here, I just output all the numbers inside of the count array. So I'm going to try to run this right now to test my program. And here you can see it outputs all the counts for all numbers. And you can see these numbers all add up to 100, so we know this is correct. So for homework 3, we were to create a program that allows the user to enter the number of students and then allows them to enter the names and scores of the students and then output both their names and scores in decreasing order. So after this, I simply had to sort both the names array and the scores array, and I did this by using the bubble sort. So the bubble sort uses two for loops, and in these for loops, it pretty much compares adjacent elements in an array, and if the element is less than an array, it will swap them. And this is because I need the largest array or the largest values, the largest scores to be first. So if the next value is larger than the previous value, it will swap this and does that here. So here it swaps in the scores array elements, and then here it swaps in the names array elements. So it'll pretty much swap the values when needed. So if the first value of an array is 3 and the next value is 4, for example, we will swap 3 and 4, and so on and so forth until we have the smallest value at the end of the array. Then after this, it'll go through the entire array again to get the second smallest value and then put it at I minus 1. And pretty much it'll do this until the array is sorted from highest to lowest. So after this, after the array is sorted, all I have to do was create a for loop to iterate to 0 to num, which is the amount of students they had, and I just outputted the names and the scores. So I'll test this right now. Enter the number of students. I'll enter 3 students. Name for the first one is John, and John's score will be an 80. I'll enter Sam for the second, and his score will be a 90. And I'll enter Mary for the third, and her score will be a 95. So I'll put Mary's score, which is the highest, which is 95, Sam's score, which is a 90, and then John's last, which is an 80. So we can see that my program correctly outputs the correct order of scores and students. So for 3.4, we were to create a program that allows the user to enter in a random number from 1 to 100, and then pretty much allows the computer to guess the number in 7 or less attempts. So I started by declaring the necessary variables. I needed num guesses variable to count the number of guesses the computer needed. I needed a bool guess variable to track whether the guess was true or not. And I needed a max and min variable to pretty much keep track of the possible values that this number that the user entered could be. Also, a random int variable, which allows the user to enter in a random number that they want. So I started by couting a message that allows the user to enter in a random value. I cout it into random. And now we just have to program the computer to guess the correct number. So my approach was to use like binary search, which pretty much just halves the possible values until it corrects like the value properly or corrects it correctly. So I started by setting the guess equal to 50 because the program will output whether it's too high or it's too low. And if it's too high, then we can guess a higher value. If it is too low, then we can guess a lower value. And we can do this because if it's too high, if it's too low, we can change the max or min to reflect that properly. So here we just check to see if the initial guess of 50 is right. And if it is, we just write correct and guess is equal to true. And if it's not, which it won't be most of the time, we run a while loop that goes as long as computer guess is not equal to the number that the user entered. So if the computer guess, which is 50, is too large, it's bigger than random, then we know that the guess has to be from 0 to 49. So I just output too high, and then we make max equal to computer guess minus 1, which would be 49. And then we add 1 to the number of guesses. So we can output this later. And here, just for example, this is in the event it's too low. If it's too low, then we know that the correct number has to be from 51 to 100. So we set minimum equal to computer guess plus 1. So we set minimum to 51. And we also would add 1 to the number of guesses. And here we just output the computer guess. And finally, here is where we edit the computer guess. So we pretty much make computer guess equal to half, like pretty much the midpoint of the max possible plus the min possible. So this will pretty much make it to where it's half of like pretty much both numbers, which is pretty much what we do for this first guess here. So the maximum number is 100 and the minimum number is 1. So halfway between this is 50. So this will pretty much erase half of values from possibility. So we pretty much do this for every iteration of this for loop. And it'll do this until it correctly guesses the right number. So once we do this, we see out the number that we have to guess and also the initial computer guess, which would be 50. And then we enter, or no, it would be the correct number that it finally guesses. And also the number of times it has to guess, the number of times the computer has to guess this number. So I'll just test it real quick. So I'll just enter a number for the computer to guess. I'll just put in 23. 23. So the initial guess of 50 is too high, so it'll guess the midpoint from 50 to 1, which is 25. That'll still be too high, so it'll guess the midpoint from 25 to 1, which will be 12. But that'll be too low, so it'll guess the midpoint from 12 to 25, or 12 to 24, which would be 18. And that would be too low, so it'll guess the midpoint from 18 to 25, which would be 21. So then that'll still be too low, so it'll get the midpoint from 21 to 24, which would be 23. So correctly guessed it in 6 guesses. So I'll just test it again, just to show. So next number will be, I guess, 76. This time it'll do the same thing, except in 6 attempts. So you can see that my program does work with multiple numbers.